I'd like to talk about a steam methane reformer, because I think that's a great heater for a lot of customers. They depend on all that hydrogen production. It's integral to many oil and gas facilities. And actually, when you think about an SMR unit, there's two things that are going on there. Big consumers of fuel, we've got volatile natural gas prices, and in kind, you've got a big contribution to emissions from that very heater operation. So we go in as a business model and we work with in this case, the SMR train, the SMR process team, and we go through their operating data. We look at a typical day's production and we try to capture exactly what they're trying to accomplish with this heater, what their future goals are. And then we take a step back, look at their design specs, any kind of revamp work they may have done, and the gap between what it used to be and what it is today is what they've lost in efficiency. And that is the gap where we try to insert the IGS technologies. We find the best fit for that heater operation so that they can improve the situation on that heater. Now, as I said, the SMR units, they have a lot of different designs out there, so it's very important that we go on site and take a good look at exactly the configuration and look at the live process data. So what do we do with all that? We come back to the customer, in this case, that process team, with our recommendations. For this particular heater, it was a fuel savings that was most important to them, coupled with an emission reduction. So it was a 2% fuel savings that we calculated, and they validated that data and how we got to that conclusion. Now, if you think about 2%, it doesn't sound like a lot, but when you think about the volume of natural gas that consumes, it's a big win for that site. So you've got a 2% fuel reduction. Now you've got an equivalent in CO2 reduction. So you're checking great things off on the emission reduction front. Plus, you get a complementary reduction in NOx. So that was going to be 9%. And you're reducing the bridge wall temperature. In this case, it was 50F. So that whole package, you put in front of the turnaround team, you look at the internal rate of return requirements for that turnaround. Are there enough days? And that's something that we also project. In this case, it was 5 days. So that whole package met their investment requirements. They had the days, they had the dollars, and we executed that project. Because the beauty is with C-Tech and Hot Tech and Tube Tech, all the IGS technologies, we're the inventors, we're the owners, we're the developers, and we're the applicators. So we fold in those technologies into how to make that heater the best heater it can be, get it back to design. So in addition to looking at the radiant section and the fuel savings from that, we also look at the convection section. Now, an SMR unit, it's really important those convection sections are maintained. You can really lose a lot. You're thinking about process preheat in those units, or even like steam crackers where it's all about crossover temperature, critical to the process. So it's all part of our fired heater team's calculations to fold that in. So there's our recommendation. Our remote operated vehicle technology to bring the convection section back to design, our high emissivity refractory coating to improve that emissivity, re-radiate energy, more energy over design back into the process. So that combination gave them a 9-month payback. Fantastic win. Now we execute the project, we do it safely, we do it on time, we go back in and revalidate all the data from the client, sort that out, and in fact, that's exactly the benefit that they got. They got their payback, they got their fuel savings, which is significant and frankly, sustainable. That's the beauty of the refractory coatings. You're talking about a 2 turnaround run. Think of it as a decade worth of benefit. And that keeps paying for itself, not just in the first year, but every year after that.